Okay, people, hello to our this class. Excellent, very good. Welcome here to the Colegio Mayor de los Andes. Hello to your math class about application for learner questions. Okay, the objective for today we're going to strong graphing learner functions using the economic with learner questions. Okay, remember that in this case we are speaking about the economic, okay, only to do example about how we can use the positive slope, okay, when we're speaking about the supply, okay, and the negative slope where we are speaking about the demand, okay, the price of quantities. It's only a method, but today we're going to understand and learn about the substitution method. Okay, so let's begin our beautiful class for today. Okay, now let's begin with this beautiful example. Okay, we was speaking about the solves of solution by graphing. Okay, but in our last class we were speaking or we was seeing like how when we was graphing that was very difficult in some very aspects when we have to wrap all the line and try to find the intercept point then that we have in some values that we have some problems to find it. Okay, we have some problems to see which is the special the point, the right point with decimals or fractionary point with the coordinates on the Cartesian plane that we can find the intercept with the axis. That's the problem that we have to say, okay, where's this the point, the specific point that we have to that we can intercept, that we can see the intercept with the equation. Okay, yes, we can solve this system equation using graphing. Okay, you know that the only thing that we can do in this case is put it all the equation in y term. For example, we're going to remember that we have one and two equations. Okay, oh, sorry for my numbers, are awful numbers. Okay, the first equation in this case minus x plus 3y, it's equal 6. Okay, now I'm going to pass to the other side. Okay, and set 3y, it's equal 6 plus x. Now this 3 pass to divide to the 6 and the x. So we have y, it's equal 6, sorry for my 6 over 3 plus x over 3. Okay, plus over 3. Now 6 and 3 we can simplify it. Y, it's equal 6 over 3, it's equal 2 plus x over 3. So we can identify here the intercept with the y-axis, okay, and we can identify the slope, okay, the slope. Remember that in this case, we have the intercept with the x-axis in 2. Look at that. This is the intercept with the x-axis in 2. Okay. Now the slope in this case we have the change in y and a change in x. It's equal to change in y, 1 position and 3 position in x. Okay, so in this case we have 1 position in y on the y-axis, 1, and move 3, 1, 2, and 3 positions. Look at that, 1, 1, 2, 3 positions again. 1, 1, 2, 3 positions again. Okay, but look at that. To graph, when I ask you that we have a awful line. Okay, when I ask you that we have to find the graph, you can do it. Okay, but look at that, all the process that I have to do to find the intercept point. Now we're going to do the second equation. Okay, the second equation is 3x. Remember, this is the second equation. 3x minus 9y equal 9. Okay, I'm going to move this one. Remember, in this case is minus 9x minus 9y. It's equal, I'm going to put this y to the other side. 9y, excuse me, 9 minus 3x. Okay, now I'm going to multiply all the equations by minus 1 to change their sign. Okay, look at that, 9y now is positive equal 3x positive. Look at that, it was negative, now it's positive. This is a x minus 9. Okay, now I'm going to move, remember, this to divide and this one to divide 2. So the answer is y, it's equal 3x over 9 minus 9 over 9. So we can simplify these expressions. Okay, y, it's equal 1 over 3x minus 1. Okay, excellent, very good. Now look at that, we have this slope, okay, and we have, in this case, the intercept with the y-axis. Remember that in this slope, the change in x represent 1, and the change in y, and the change in x represents 3. So we're going to begin, okay? With this minus 1, okay? Put minus 1 on the y-axis. Very good. On the y-axis. Now minus 1. Now we have to move 1 in y to move 3 in x. 1 in y, 3 in x. Very good. 1, 1, 2, 3. Okay. 1, 1, 2, 3. Okay, but look at that. 1, 1, 2, 3. We have a problem. Look at this one. This is moving in parallel form. Look at that. So we don't have intercept in this case. Look at that. Same point is here. Okay, look at that. Move in parallel structure. Okay, in parallel structure. So look at how, in this case, this system of equation by graphing move in parallel form. So it's difficult, it's important to know it. Look at that. So now we have to identify the special system of linear equations. Okay, there are 3 possible outcomes when graphing 2 linear equations in a plane. Okay, one point of intersection, it's one solution. Parallel lines like this one, okay, look at that, like parallel lines, we have no solutions. Or coincident lines, infinite numbers of solutions. If there is at least one solution, the system is considered to be consistent. If the system defines distinct line, okay, the equations are independent. Okay, so please, possible solution of linear equation. Look at that graph. Two lines intersect but one point. Number of solutions. If this line intersects the system of equations have one solution given by the point of the intersection. Okay, so it's consistent and the equations are independent. Look at that. We have parallel lines like the equation, like the graph that we can do. Okay. Look at that. If the lines are parallel, then the system of equations has no solution because the lines never intersect. So the type of system that is inconsistent and the equations are independent. Okay? And when the line consists of the lines on top of each other, okay? Then the system has infinitely many solutions, have infinitely many solutions. The solution set is a set of all points, okay? They are consistent and the equations are dependent, okay? Very, very good. Okay, please, I'm going to read some comments. Uh, please, Samuel Borda, please, I know support I know is Samichuelo, that it's Burgos, please, Burgos. Um, please, Mariantes, please, we are paying attention over the process, okay, to our class. So please, everybody, I need that everybody pay attention. Please, Borda, please, Mariantes, okay? Okay, here, everybody, hello to everybody that I didn't say hello, okay? Hello, Marinova, how are you? Thank you for your help. Majo Lorenzo, thank you for your help. Thank you so much. Okay, I don't want to use Zoom because Zoom it's have a lot of problems. Okay, please, I need that everyone use your personal, your personal mail. Please remember, I need that everybody use your institutional mail, please. Okay, please connect with your institutional mail, please. Okay, very, very good. Okay, let's begin. Okay, so remember, when the graph have the intercept, we have two lines intersect one point. Okay, if we have number solutions, the lines intersect. Okay, we have parallel lines, it's inconsistent and the equations are independent. Okay, and when the line consists, it's consistent. But look at that. We're going to learn today the substitution method. So I need that everybody put attention. Okay, another method that can be used to solve system of equation is called the substitution method. To use the substitution method, we first need an equation solver for one of these variables. Then substitute a new expression, the variables, into the other one. So it's necessary that everybody pay attention to this structure. Okay? Now, look at that. That this equation, the second equation, we have the first equation, okay? And the second equation, Look at that, how at the second equation sets y it's equal, okay, to 3x minus 3. It's equal. So I can replace this equation into the first one, okay? Look at that. And now, look at that. Like in this case is 6x, oh, excuse me for this x. 6x minus 4y, but y is 3x minus 3. Okay? Okay, excellent. 3x minus 3 it's equal 10. Now 6x minus, we have to multiply the signs, okay? Remember, minus times plus minus 4 times 3x, 12x, minus times minus plus 4 times 3, 12, equal 10. Now, we can simplify the expression. Look at that. This 12 can go to the other side. And this 6x minus 12x can be simplified. Okay? 6x minus 12x is minus 6x equal 10 minus 12. Okay? Minus 6x, it's equal 10 minus 12, it's minus 2. Now, look at that. Look at that. That we can multiply all the expression by minus 1. In this moment, Mariana is saying, I don't know why the both operations that I can substitute, because this is the substitution method, Marianita. I'm going to substitute this y into this y. Look at that. This y into this one. Look at, say, y is equal 3x minus 3. Okay? And look at what happened in this case. Now, look at that. Very good, Sammy. Because y is equal to this. Very, very good. I'm going to multiply all the expression by minus 1. Okay? So, in this case, we have 6x positive equal 2. Okay? And now this 6 pass to the other side to divide. X is equal 2 over 6. And we can simplify this expression. So in this case, it's 1 over 3. So x, it's equal 1 over 3. Now, we now have this number, okay? 1 over 3. 1 over 3. Now, you can replace it again, this answer, in this equation if you want, okay? In y equation. And say y is equal 3x minus 3. But remember that x is 1 over 3. Okay? So we have y is equal 3 times 1 over 3. Okay? Minus 3. Y is equal 3 times 1 over 3 is 3 over 3. Okay? Now, 3 over 3 over 1. Okay? Now, y is equal, we're going to simplify the expression, y is 1 minus 3. So the value of y is minus 2. Okay, so now we have the answer in this case. Okay, the x value is 1 over 3, so the reference is 1 over 3 and minus 2. Okay, now I'm reading to Mateo saying, teacher, remember that the sign is positive and was negative. Mateo, look at that. We have negative times positive, negative. Negative times negative, positive. Okay? Move 12 to the other side of the equality and pass to the negative form. And 6x minus 12x, it's minus 6x. It's fine. Okay, don't worry. First, it's negative. Okay, Mateito? Look at that. First is negative. Because the 4 have negative form. Minus times plus is minus. Minus times minus it's plus. Okay, look at that. Now 6x minus 12x minus 6x. And 12 minus 12, 10 minus 12, it's minus 2. Later, you can multiply by minus 1 to change the signs. 6 in positive form and 2 in negative form. Okay? Very good. If you are doing in this case. Okay? Very, very good. Now, look at that. We have this equation, this structure, we have this coordinate. In this form, using the substitution method, we can now, if it's true or no, it's true, the equation that we're doing, okay? So this coordinate is the point where the lines are intercepts, is the intercept with the point, okay? So it's necessary that you use the substitution method in some exercise. Some ignorantes say, but why do you put 3x minus 3? Because this is the y value. It's because you are speaking so loud. You are speaking a lot of with your friends using the chat. I need that you put attention. Okay? Very good. You have to replace the y answer into this y. For this reason is the substitution. We're substituting the y for the 3x minus 3. Very good. Excellent. Very good, Alejandro and Mariana. Thank you. Thank you because you are saying the truth in this moment. Okay, so let's continue. Let's continue. Remember that when we have some doubts, you can see or you can watch again the video using our YouTube channel because this video will be uploaded in 20 minutes. In 10 minutes, this video will be uploaded. Okay. Now, remember for class 10 and 3. Okay. So everybody, we need you. I need that you go to very good activity to Desmos. Okay. Please go to Desmos and put the next code. Okay, remember that you have go to the student.desmos.com and you have to put this code and we're going to match some lines using the lines, okay, using the linear equations. Okay, so I need that everybody use the real name, put your real name into, okay, into the x value. Okay, Okay, the connection was broken for one moment. I don't know what happened, but again, we are in line. Okay, I don't know what happened with the connection, and I don't have the same network connection of Catalina, of Miss Catalina. It's different. Okay, but we are online again. Okay, the code. Okay, everybody, please put the code. Put the code. Now are Mateo, Mariana, Ana Sol, Samuel, Valeria, Maria Paula, excellent. Samuel Burgos, Alejandro Galvis, excellent that you are there. Excellent. Oh, okay, Pata. Hello, Pata, how are you? Hello, Valencho. You have to put the code in go to student.desmos, student.desmos.com, and you have to put the code, but don't put it. You'll have a continue without singing. Okay? Remember that you have go to student.desmos.com. Okay, I don't know why you can't, because in this moment Sara Sarmiento, Samuel, Alejandro, Samuel Burgos, Felipe, Anasón, Mariana, Mateo, Valeria, Maria Paula are in are into Desmos. I don't know what happened. Okay, look at that. Okay, remember that the code appear on the right, at the side, of the left side. Yes, of the left side of the web page. Okay. And so say it doesn't work me. Why? I see you here. Look at that. In this moment, I can see Maria Paula, Valeria, Mateo, Mariana, and so. Okay, now do the activity. You only have to do the activity. Okay. Alvis, you have two wrong. Okay. Yes, it's difficult. No, it's not difficult. Okay, remember that you have to pass the slides, okay? Because the first one are only for presentations on the Vulkan, okay? Okay, you have only 9 minutes. Okay, the exercises are only 1 to 10. 1 to 10. The 1 is the welcome, so it's not difficult. 1 to 10. Why you don't know, Julian? Go to student.desmos. I don't know. I'm going to go and remember the student.desmos.com. Okay. And come on! Set welcome. Enter to your class code. Student.desmos.com. What happened? Appear the code. Look at the code. CQD BCT. BCT. Join. And continue without singing. Continue without singing. And later appear enter your names to begin. What happened to my friends? Okay, that you're not reading. Come on. You only have to put the code in student.desmos.com and later only say uh, go without singing. Excellent, very good. Now you're there. Santi, are you in 2 times? You have to choose for Sami Bernal. Julio, very good. Juanjo Pataquiva. Samuel Bernal. Gabriela Serrón, excellent, very good. Excellent. Maria Paula have 1, excellent. Alejandro Galvis have 2 right and 3 wrong. Okay, excellent Andres, excellent Sarmiento, very very good. Okay, remember that we have only 2 minutes more. 2 minutes more. Okay. And why now? You're not in pause and so. Okay, you can do it now. Okay, very very good. Excellent. Remember that in some exercise you have to check the intersect, okay? That you have to plot for lines or you have to adjust the line, okay? Remember we are speaking about the linear equations, we are speaking about the substitution method to find the intersect with other lines, okay? Very, very good. Doesn't appear me like you're wrong, Juanjo. Sarah Juli. Appear me like that. Personal. Okay, please, everybody. We have to continue. We have only 5 minutes more. Okay, excellent. And Surrender, you are working. Excellent, very good. Okay, Julis, desire that you doesn't appear. Okay, I'm going to find you. David Ceron, Marco Lorenzo, very good that you're there. Juanjo, you are the welcome. You have to move the slides to the right side, okay? So why are you cannot in? Tell me, appears something in your internet connection? Don't worry. If you have problems with the internet connection, later we can do the activity, okay? Don't worry. Okay, very good. For the people that are working, very good. Alejandro Galvi is excellent. Bueno, very good. Cepeda, Sarmiento, Samuel Andres, Mariana Castro, excellent. You're working. Santi, very good. Samuel Bernal, excellent that you did the first one. Very good. Julian Ortiz, okay, thank you that you're working, but look at that, you have three exercise rank. Okay, it's very difficult. Don't worry, it's because we are learning about the how to move the learner equation, how to move the learner on the Cartesian plane. Okay, very good. At the page, I mean, it's a student that desmos.com. Okay, it's that's the web page, but don't worry because now we are I'm going to pause the activity. Okay, please, everybody, remember that today we are speaking about the substitution method. That in some equations we can look, like in this example, that we have parallel lines. Look at that. Remember that when we have one point of our transaction, we have only one solution, that parallel lines have no solutions, okay? And the coincident lines have infinite numbers of solutions. Remember that the graph with one intercept is consistent and the equation are independent. That we can find parallel lines that are inconsistent and the equation are independent, okay? And we have line coincidence that one is top of other one, okay? That are consistent and the equation are dependent. Remember that we are using the substitution method to find the solution of the equations, that we have to replace the system, the equation of one equation, the answer, we have to replace it into the other one and try to find the x value and later replace this x value. Okay, remember, remember everybody, today we was speaking about the substitution methods and we are speaking about the intercept lines and parallel lines. So please everybody, now uh, we're going to finish our class. Remember that we have go to take some food for today, okay? And we're going to continue our next class, okay? And you are very important for me. You are in my heart, in my soul, in my mind. Please don't speak a lot in the chat, okay? For this reason, it's better use this one or now use Zoom or Meet in some cases, okay? So, everybody, I love you so much. You are in my mind, you are in my heart, you are in my soul. And bye bye.